The problem says a particle hangs at the end of a light inextensible string of 0.6 meter length. What is the amount of minimum velocities must be given to perform circles? That is, to perform vertical circles. So let's say it's here. I don't know, maybe let's draw it here. And what velocity it needs to be given so that it goes like that, a vertical circle. So essentially, if we recall the previous video, we are talking about velocity at the bottom, VB here, and here when it is the top position we called it VT. So we will go back to the energy considerations. At the top position, its energy is, if we say the radius, the string length is given, which is 0.6 meters, which is the radius basically. So this height is of course 2r, that is 2 into 0.6, but we will use just r for the time being. So the if we say the mass of the object is m, energy, kinetic and potential energy at top position will be mg times 2r, and kinetic energy will be half mvt square. So I'm just rederiving the equations quickly. I did that in the previous video, but this time quickly. Vb square, which is bottom. So basically this is the kinetic energy at the bottom. It will have only kinetic energy at the bottom, and this is the potential energy plus the kinetic energy at top position. So from here we saw, then if we consider the tension at top position, this will be plus mg, both towards the center. Weight is also towards the center and tension is towards the center, equals to centripetal force, which will be mvt square over r. So tension has to be at least 0 or greater than 0. So from that we could say mvt square over r is greater than equals to mg, which leads to vt is greater than equals to square root gr. Then if we go back to this equation, we can say half mvb square equals to half mvt square plus mg into 2r, this becoming half vb square greater than equals to, let's say, instead of this one we want to write well, what we should have done is, let's get rid of all the m. So yeah, I will write one more line. So from here we get to half vt square plus g is going away, so g into 2r. Now this one we can write greater than equals to half, instead of vt we're writing this one, so greater than gr plus square plus 2gr. So vb is becoming after 5gr. So that's what it's becoming. So we will now write the values here. So minimum velocity, this is the velocity because it is at the bottom position, it is just hanging. Now what's the velocity? The minimum velocity it needs to be given. So that will be Vv will be greater than equals to 5 times g, which is 9.8 meter per second square, times 0.6, that's the radius. So that one gives us 5.42 meter per second. So that's it.